Yancy, welcome. How are you feeling today?
Terrified, but excited.
You're going to do great.
Thank you.
All right, good luck to you.
Thanks. Hello, everyone. Today, I'm here to present EcoCycle, our innovative organic waste management solution. We will begin our presentation by looking at our solution and its relevance to circular economy. Following that, we will delve into our business model and its real-world implementations. Organic waste management is a complex, wicked problem in China. Each year, China produces an astonishing amount of organic waste, over 6 billion tons, including livestock, manure, and crop straws. However, the common disposal methods are outdated and inefficient. For example, less than 33% of crop straws and 40% of manure are repurposed by these two methods, leaving the majority of the waste becoming secondary pollution. Despite the urgent needs for improved solutions, emerging methods are challenging due to financial constraints, insufficient facilities, and regulatory barriers. That's why we developed the EcoCycle, our innovative waste management solution that encompasses three key elements. The first one is Aurifori software. It's patented soil analysis and fertilizer fermentation platform that predicts precise decomposition blends for over 50 crop types based on local soil, climate, and waste conditions. This platform then guides an automated system to combine microbial agents and enzymes with this waste for advanced pretreatment. This catalyst can accelerate chemical reaction and optimize nutrient upcycling. Lastly, the LVAR processor is a patented intelligent waste decomposition device that breaks down large biomass waste into small molecule carbon sources. With its compact design, this processor ensures decomposition efficiency while reducing energy consumption and secondary pollution. By combining these three elements into one single unit, we can achieve higher waste utilization rate, lower energy consumption, faster processing time, minimum environmental footprint, and on-site solution that's leading to enhanced fertilizer quality. Our waste management cycle is straightforward, but yet highly effective. It starts with the collection of waste from breeding and planting farms. With Aurifori system, the enzyme and the microbial agents are added for pretreatment. Within the processor, the waste undergoes enzymatic degradation and transforms into small molecules in three states: gas, liquid, and solid. These molecules are ultimately converted into liquid and solid organic fertilizer that can be used by the planting farms, completing the closed-loop waste management cycle. Our solution is rooted in the three core principles of circular economy: eliminating waste, circulating products, and natural regeneration. First, we eliminate waste not only through the upscaling of the waste itself, but also through the reduction of secondary pollution. Next, our solution supports continual product circulation through both biological and a technical cycle. In the biological cycle, the waste converts into fertilizer that can boost agricultural productivity. In the technical cycle, our device is produced from stainless steel that can be reused, recycled, and remanufactured to maximum its value. Lastly, we favor natural regeneration by using organic fertilizer over chemical alternatives, aiding in ecological recovery and ecosystem conservation. Our solution aligns with several sustainable development goals, underscoring food quality, public health, innovation, sustainable communities, and responsible production. Our business model is a joint venture between EcoCycle and the partnering breeding and or farming, planting farms. The partnership is rooted in collective operation and mutual investment in consumables, equipment, and technology. By merging resources and expertise, this model enables both parties benefit financially from the use and sales of organic fertilizers. Let's take a look at the largest partnership we have forged so far in a cotton village in Xinjiang. This village has more than 400 farms with a combined area of 10,000 acres. Collectively, they produce 4,000 tons of organic waste, requiring 750 tons of chemical fertilizer or 20,000 tons of organic fertilizer. Recognizing the potential of this cotton waste, our solution steps in and converts them into organic fertilizer tailored for these cotton farms. With the fertilizer, they can cultivate high-yielding cottons vital for the production of high-quality clothing. And the magic of our solution is that we can collect cotton crop straws and discarded clothes back into our system for reproduction of fertilizers. During our trial phase, we process 25 tons of organic waste and produces 30 tons of organic fertilizer daily, with 30% less in water usage and 25% less in chemical usage. When in full capacity, our solution can satisfy over half of the annual demand of the organic fertilizers in this region. The competitive analysis highlights that our solution in dark green overshines our competitors across multiple key metrics. Looking at the SWOT analysis to the right, EcoCycle exhibits a host of strengths that I just covered. At the same time, we also face challenges such as upfront investment, upscaling from small-scale trials, high cost of R&D. However, the landscape also brings opportunities such as more stricter environmental regulation, increasing market demand, and agricultural modernization. Against this backdrop are threats such as stiff competition, regulatory adjustment, and fluctuation in downstream market conditions that may pose a threat to our market stance. Looking forward, we aim to expand in key agricultural regions by collaborating closely with local partners to establish manufacturing facilities, just like what we have achieved for Xinjiang for that cotton village. Additionally, we aim to advance our equipment and technology to produce byproducts beyond our agricultural scope, such as biomaterials for soil remediation, wastewater treatment, and biofermentation. Before I conclude, I want to thank to all my team members who cannot attend today due to visa requirement for travels. And lastly, I want to thank you all for your attention. If you have any inquiries or feedback, please feel free to contact us. Thank you very much.
Great work, Yancy. We'll give the judges a minute to talk. Let's chat, you and I.
Sure.
I did read in your bio that you are a former ballroom dancer.
I was a ballroom dancer.
Yes, tell us about it.
Well, there's nothing really much to talk about it, but I have been dancing for quite 10, 12 years before going to college. And then I kind of quit it and just danced socially.
Fantastic. Love dancing. It's so good for you, right?
Yeah, it's really nice to connect with other people.
Truly, truly. I also read in your bio you visited 66 countries.
I did. I love traveling. That's my biggest hobby.
And how has traveling inspired your love for the circular economy and doing work in sustainability?
I think traveling doesn't really do much to the circular economy because it's a lot of waste and the pollution, I guess. But yeah, my motivation for circular economy is not from traveling, but more like from my past work experience in startups, and that's kind of caused me to enter this competition as a health economics background, because I know nothing about agriculture, I know nothing about enzyme microbial agents, so I have to pick it up and learn myself.
Good for you. Congratulations.
Thank
you
you
for sharing. Judges, all set. Good luck.
Thank you very much for your presentation. That was excellent. I have a question about the technologies that you're bringing together for your solution. My two-part question. First of all, did you and your team develop the technologies and patent them? So that's one question. And then the second is, do you have exclusive rights to these technologies, or are you planning to license them to others? What does that look like for you?
Yes. So to answer your first question, all the three components are developed in-house. So the equipment, the software, our reforest software is kind of started from a master thesis with Shanghai Jiao Tong University. And also the enzyme and the microbial agents is also another academic project within the same lab, but from different team member. And the device, the first device, we don't see it anymore, but the concluding slide, we have a device that's for small factory. And that's what we developed before, but entering this competition, we kind of want to first focus on small-scale farms at the beginning. So we presented these compact portable devices. But later on, we found out that we can really upscale our solutions to larger communities, and also there's a huge amount of investment for the small-scale farmers. And that's why we are building larger manufacturing facilities. And so yes, for your second question, whether we are going to license it, we are not sure yet, but probably in the future, we'll consider it.
Thank you very much.
Okay, so yeah, I must have missed the really intriguing idea of being able to bring in things like spent cotton clothing in your original proposal, which is why it's great to actually have you stand there. These face-to-face presentations are really important in that. My question is, because I'm really intrigued about this, is how do you deal with dyes and all the other toxins that perhaps go into the clothing manufacturing process?
Yeah, for sure. So the presentation is an idea. So that part, recycling discarded clothing, isn't really achieved because we are just in the phase 1 trial, and it was just 1 month. But that's the idea that we are going through, and we are trying to advance our technology to deal with all those. But we did have another case that we presented in poster that concludes actually. So we actually recycle. It's for an orange juice factory. So we actually collected the orange peels and recycled back into system to produce more fertilizer. But for the clothing, for sure, there's some sort of different decomposition blends that we have to take and consider into. Yeah.
Tusen Dank. Where are the enzymes and the microbes coming that are part of your system? Where are they coming from? And also, how in total is this different from current practices of on-farm composting?
What's your second part of the question, sorry?
How is your system different from current practices of on-farm composting?
Yeah, so the microbial agents and enzymes are kind of developed within the lab. And you can think of our machine as a coffee machine. So we kind of put them inside the machine, and they automatically determine what's the optimum amount and variety of them. And before we send the equipment, they will send the sample of the soil and waste conditions, and then we will go through this platform and predict what would be the best, possible microagents and enzymes that would be beneficial for this specific farm and crop types, and that's our solution. And we have around 15 to 20 different types of microbial agents and enzymes. And those, I wouldn't say they are very different from the existing market, but it's sort of some of different. There's a small variation that's to increase productivity and efficiency. Yeah.
Can I just add a follow-up on that one? So the different microbes that you need to customize for different farming setups.
Right.
That sounds like a business unto itself in terms of being able to produce and customize. How do you aim to do that? Will it be do you plan to move that out of the lab at some point, or would you do that in a university? How do you plan to service that market?
So it was actually lab production before, but now it's kind of like part of us. Yeah. So it's like purely our own business within, just like the device itself. We have a production team for that device, and we have production lab team for the enzyme and the microbial engine.
Thank you.
I have a question on patents. You said your organization has already 2 patents issued. Those normally take a number of years.
Yes.
And then you mentioned a company or something called Clark Duran, and what is that? Clark Duran, it was on one of your slides.
Yeah, so he's the CEO of that Ori platform, and that's the master thesis project of his, and that's eventually developing into a company, and yeah, that's that company.
But how long has the company then existed to get these patents?
The company didn't exist much long, I think 2 to 3 years, but the technology has kind of advanced over the past couple years, like from at least 5 years.
Thank you.
Yancy, congratulations for making it to the finals.
Thank you.
And your project is really interesting in the fact that you have been able to optimize so many things, the enzyme, the bio refining, and so forth. You mentioned in your presentation that it has the potential for reducing some of the inputs by 25%. Have you done any projections on what you think the ultimate optimization of the process might be?
For reducing chemical fertilizer, or?
I think what the 25% was the organics, right?
No, so we reduced the chemical use by 25%, but we produce the organic fertilizer that satisfy more than 50% of annual demand when in full capacity.
Okay, then my question is on the chemical input. What do you think the optimal optimization might end up being?
That really depends on how technology advances in the future, and we aim to reduce chemical use as much as possible. But the thing is, you kind of part of the inputs that we have was also the chemical fertilizer that used in the system. So you also have to add a chemical fertilizer.
I have a question regarding, you used your product for the reclamation of salt-affected soils. How you did that? And what were the results? Because salt-affected soils have very low biological activity, plus the high salt content,
Right.
So how your product will kind of reduce salt content?
Right. I'm not the person who would be able to answer that question, because I'm the least person in our team to know the core, to know about a soil and plantation. But I'm sure I can find an answer later on if you want to have a chat.
Perfect.
I just have a quick question. In terms of your development as a team, can you speak a bit to, are you incorporated as a company already, or are you bringing together existing technologies from existing companies? I guess I'm a little gray in terms of where you're at.
We are not really a company at all. So we are at least ideation to implementation phase. We are running different small-scale trials, and the cotton factory is actually the only large factory we are building right now, and we are still testing what's the productivity of the fertilizer and everything. But before that, we had like 3 small-scale trials within Shanghai, and those for different mix of different vegetable crops, and also the orange factory that I mentioned. So yeah, we are in the trial phase for business to coming, but we are not a business right now.
Thank you.
Excellent. Great job, Yancy.
Thank you so much.
EcoCycle.